Hello, my fourth grade friends. Today we are working on Unit 2, Lesson 15. Before we start with our page, we're going to do a little work on the whiteboard. So just to sort of not jump into the middle of things. So we've talked about a bunch of different strategies for multiplication of two-digit numbers as well as other things, but now we're talking about practicing some of those methods. And to start us off, we'll start with one of the more complicated ones, and then we'll like narrow it down to the ones that have less writing but a little bit more going on in your head. And when I said complicated, I just meant like ones that you have to write a lot for, and then as you can start doing some of the steps in your head, then it simplifies what you're writing, but you're still doing all the same stuff, right? All right, I'll just start doing the math. Here we go. I want you to write down on your whiteboard 67 times 43. Okay? So you know that 67 in expanded form is 60 plus 7, right? And you know that 43 in expanded form is 40 plus what? 3, right? So then you can just multiply each chunk by each chunk just in the same way that you would do in the area model, right? So let's do 7 times 3. What's that? 21. And then let's do the 3 times the 60. What's that? Done that to that. Now we'll do this to that. 3 times 6 is 18, so 18 tens, right? Because it's 6 tens, so 180. Then we'll do the 40 times the 70. So, which we can bring those tens out to the side so they're timesing by each other. So that's 100. So 4 times 7 times 100. What's 4 times 7? 28. 2800 is 2,800. Oh, I'm so silly. What am I doing? That's not 70, it's just 7. I was like, wait a second, why is 40 times 7 so big? Oh my gosh. 28 tens. Then, here we go. 40 times 60. That just demonstrates why you always got to pay attention to what you're doing, So now we'll multiply those tens to each other and keep them off to the side. And then multiply the 4 and the 6. What's 4 times 6? 24. Now it's 2,400. Okay. And then we'll add all those up. That was 18. This is 100 plus 200, 300 plus 400, 700, and then 800, and then 2,000. So 2,881. Now, for one math problem, our glare is kind of annoying, isn't it? Or what if I do that? Now it's, that's better. Okay. So it's a lot of writing, right? And there are some things we can do to make it quicker for our hands as long as our heads are feeling comfortable with it. So rather than writing out this and this, we could have just written this part underneath. As long as we knew to multiply 3 times 7, 3 times 60, 40 times 7, 40 times 60. And the important thing, and this is something that caught up a lot of kids when I was learning this as a child, was they would see this and they would think, oh, 4 times 7. No, 40 times 7. That's why we bothered spending the time breaking things into expanded form to make sure everyone knew this is not a 4. This is 4 tens, right? 40. So if you start multiplying just like 4 times 7, it's you're going to be off, right? And in math, you don't want to be off. You want to be right on the money. So just to do it simply over here, without all this part, we'll do our 67 times 43. 3 times 7, 21. 3 times 60, 180. 40 times 7, 280. 40 times 60, 2400. Add them up. Same thing, right? With like way less space taken up. So if your paper is like running out of space, this is maybe something you want to do. Some people like to shorten it even more and add these two together in their heads. I'm kind of against that idea just because I'm worried I would forget or like add it wrong in my head and then have it on the paper and then not be sure where I made my mistake. I think this is a good place to simplify it enough for me. Okay. Some people like to make some small twos, you know, like what your parents probably do, which is the way I learned it as well. 3 times 7, they would put a little 2 right here, 21, and then 3 times, this is called the shortcut method these days, 3 times, let's say 6, but it's 6 tens, so that's 180, right? Plus that 2 tens, so that's 200, which is really these two combined, right? 201 is 180 plus 21. Then what they'll do is they'll go over here and they'll do 40, they'll put like, we learned a magic 0, but it's really because you're doing it with tens. So then you have 4 times 7, 28, put then another 2 there. Maybe they'll put it up here. And then 4 times 6 or 4 tens times 6 tens is 24 plus that other 2, so 26. And what you've just done here now is added those two together, right? And then add it up, what do you get? Guess what? The same stinking thing. It's the same number no matter which way you do it, because math is systematic and organized and just a bunch of rules to help us understand all these numbers and their relationships to one another. So we're going to practice today this one first, and that's what we're going to start with in our book. So I'm going to go ahead and erase that. That one is called Shortened Expanded Notation, which I think is just a funny name because it's like it's short, but it's long, but it's short, whatever. All right, here we go. I think I'll turn my light back on. Woo! There we go. Okay. Okay, so we'll do the shortened expanded notation, which is just writing out each of the partial products before we're doing anything like the shortcut method. So 8 times 9. What's that? 72. 9 times 30. What's that? Well, 9 times 3 is 27, so 27 tens. 50 times 8. What's 5 times 8? 40. So 40 tens, so 400. And then 50 times 30. So those two tens can whoop up to the side, multiply together because of that commutative property, and they're 100. 5 times 3, 15, 1500. Let's add those up. 2, 7 plus 7 is 14. 2 plus 4 is 6, plus 5 is 11, plus 1 more is 12. Okay. Now we'll do the shortcut method. 8 times 9, or 9 times 8 is 72. 9 times 30, 27, plus 7 more is 34. So really that's just these parts put together. Then, now we're working in the tens place. We'll put that 0 there. 5 times 8 is 40. 5 times 3, or 50 times 30, is 1500, plus the 400, right, from earlier. So now we have 1900, and that's just these two parts put together. Or you could say 5 times 3 is 15, plus 4 more is 19. And then we add them all up. And guess what? It's the same thing. Pretty neat, right? All right, let's go ahead and do a little more practice. If you're feeling good, go ahead and try these two before we go on together. If you want to stay with me though, of course it's always okay. But you know, be brave. Like, what's it gonna hurt? You get one wrong, you know? That's what practice is for. Solve using any method and show your work. So if you really want to draw the rectangle, I'm not gonna stop you, right? That's always an option. Let's do, I want to do it like this. I think that's the easiest way. I don't have to do a lot of mental addition because I don't want to mess it up. Let's do 43 times 22. 2 times 3 is 6. 2 times 40 is 80. 20 times 3 is 60. And 20 times 40 is 800. So 946. And then we're going to think about it. If you have like 40 times 20, this should be a little bit more than 800. Is that a little bit more than 800? Yeah, it's a bit more than 800. Not like way more, but a little bit more. All right, let's do this one. 25 times 15. 5 times 5 is 25. 5 times 20 is 100. 10 times 5 is 50, and 10 times 20 is 200. Five, 7, 3. 375. Now let's think about this. I always, when I see 25, I like to think about quarters. If I had 15 quarters, would it make sense to have about $3.75? Well, if I had 10 quarters, that would be $2.50, right? If I had half of that, it's like less than the $5, right? So yeah, I think that makes sense. Okay, let's do this one, and I'm gonna try this shortcut method here. Let's do 31 times 62. Put a little line here so don't get confused. 2 times 1 is 2. 2 times 30 is 60. And then put a 0 there because now you're working in the tens place. 60 times 1 is 60. And then 60 times 3 is 18. And if you think about this, should that be a little bit more than 1800? Yeah, that makes sense. Let's see, 1922. Okay. If you're feeling up for it, try the last 3 on your own and correct them with me. See what you get. So we have here 54 times 72. Let's do this method. I think it's nice. 8. 2 times 50 is 100. Now 70 times 4, 280, right? And then 70 times 50, 3,500. Okay. All right, this one here, we got, I used a different pen color so I don't get things mixed up. Let's use this blue, it's pretty. 81 times 33. 3 times 1, 3. 3 times 80, 240. 30 times 1 is just 30. And then 30 times 8 again is, no, but it's 80, so it's 2400. 100. Oh, whoops, 3, silly me. 7, 6, 2. 2,673. This is why you don't want to be doing your math in pen like I am. I just do it because it's easier for the camera to pick up, but pencil's best. Okay. And just for fun, let's do this one in the rectangle, the area model. All right, 40 and 9, 60 and 2. 60 and 40, 2,400. 60 and 9, 540. 40 twice is 80, and 2 times 9 is 18. Let's add those up. Let's see. Those together is 558, and those together is 2,480. This up down here on the words of practice multiplication. 8, 13. Now it's a 10. 3,000, or yeah, 3,038. Okay. Now let's use that stuff with some word problems. And I'm going to use my whiteboard, and I encourage you to do the same, because sometimes it's like not enough space. You don't need to have it all hard to read, you know? Okay, practice multiplication. With practice, you'll be able to solve a multiplication problem with fewer written steps. Between his 9th and 10th birthday, Jimmy read 1 book each week. There are 52 weeks in a year. If each book had about 95 pages, about how many pages did he read during the year? Since this is kind of like estimating one, we'll write about. And I would think, I mean, I'm not writing the problem here, but just to quickly estimate, 95 is super close to what? 100. So 5,200 is just going to be a little bit higher than what the number we'll multiply and get is, right? So let's do 52 times 95. 10, 250 for 5 times 50. And then in the tens place, 90 times 2 is 180. And 90 times 50 is 4,500, 4,500. 14. 2 plus 1 is 3, plus 5 is 8, plus 9. So I said it was going to be a little bit under 5,200, and I'm right. Look, it's 4,940. Go me. Go you. Good job. So 4,940 pages. All right. Sam's father built a stone wall in their backyard. The wall was 14 stones high and 79 stones long. How many stones did he use to build the wall? Okay. 79 times 14. 9 times 4 is 36. 7 times 4, or 70 times 4, I should say, is 280. I don't know if you could hear that. There's like a really loud honk outside. And then 10 times 9 is 90, and 10 times 70 is 700. 6. 9 plus 8 is 17, plus 3 more is 20, and then 7 plus 4 is 11. So 1,106 stones. Balloon Bonanza sells party balloons in packages of 25 balloons. There are 48 packages in the store. How many balloons are in 48 packages? Go ahead and give that one a shot. See what you can do. Hit pause and hit play when you're ready for me. All right, so 5 times 8 is 40, or 8 times 5 is 40. 8 times 20 is 160. 40 times 5 is 200, and 40 times 20 is 800. See what we get. 1,200. 1,200. Isn't that nice? I like it when it has zeros at the end. I don't know about you. I think that's fun. Okay, here we go. Brian is buying t-shirts for the marching band. He knows that at parades, the band performs 24 rows. Each row has 13 students. If t-shirts come in boxes of 100, how many boxes of t-shirts should Brian buy? Ooh, I like this one. Because not only are we trying to figure out the number of students, but we have to make sure we have enough shirts for all the kids, which means we have to decide if we want to go low or go high. We don't want some kids in the marching band not having shirts, right? That's not very nice. So let's go ahead and first figure out how many kids there are. 24 rows, each with 13 kids. 3 times 4 is 12. 3 times 20 is 60. 10 times 4 is 40. And 10 times 20 is 200. Okay, now there are 312 kids in this band. If we buy 3 boxes, we will have 300 shirts. If we buy 4 boxes, we will have 400 shirts. Which would be the right number of boxes in order for each kid to have a shirt? 4 boxes, right? Because then there's some extras, right? Maybe you get some new kids moving in or whatever. Some kids join the band and you can have some extras. But that way, at least all these kids will have a shirt, right? So 4 boxes. Alrighty, my darlings, join me next time when we use the area model to multiply by thousands. But that's it for today. Thank you so much for joining me, and I'll see you next time. Bye-bye.